Good morning. This is your Stat Sensei, Mr. Spensei, and this is Death Packet videos for proportions, and this will be problems 21 through 30. A one sample z-test for a population proportion P will be conducted. Which of the following condition checks that the sampling distribution of the sample proportion is approximately normal? Sample is selected at random. Required, but does not check normality. NP must be greater than 10 and N times 1 must be 10 must be greater than 10. This is our answer. The sample size is less than 10 or equal to 10% of the less than or equal to 10% of the population size. This is also one of our conditions, but it's not the one we're looking for. We're only looking for B. 22. A hypothesis test was conducted to investigate whether the population proportion of students at a certain college who went to the movie theater last weekend is greater than zero point 0.2. A random sample of 100 students at the college resulted in a test statistic of 2.25. Assuming all conditions for inference were met, which of the following is the closest to the p-value of the test? Ooh. So this is a proportion test, and proportions are z, so they're telling us z equals 2.25. So let's draw a picture here. So we have a mean of 0 and a z-score of 2.25. We want to know the likelihood that we're in this tail. Well, we don't have to do this the way we normally would. We could just do a norm CDF. And if I were to do a norm CDF, I go, oh, my lower bound, 2.25. My upper bound, positive infinity. My mean, all z-scores, because we're working with z-scores, all z-scores have a mean of 0 and a standard deviation of 1. So, second vars, norm CDF, lower bound, 2.25, because that's my test statistic. Upper bound, 9 to the 99th. Mean of 0, standard deviation 1. And I get a value of about 0.0122. That's a really good question. I would start that one and come back to that, study that one if I were you guys. All right. 23. A recent survey of cell phone users indicated that 56% of the respondents prefer to use cell phones for texting rather than for making phone calls. All right. A 95% confidence interval for the estimate of all cell phone users who prefer to use cell phones for texting has a margin of error plus or minus 3%. Assume all conditions for inference have been met based on the confidence interval. Which of the following claims is supported? All right. So first off, 56 plus or minus 3. Well, if I subtract 3, that means it could be as low as 53 or as high as 59 if I add 3. So I'm 95% confident that it lies within this interval. So less than half prefer texting. No, not even possible, not there. More than a half of all people prefer texting. Kind of liking that one. All right. At least 60%. Nope, it's less than 60%. At least 75, at least 95. At 95, they're trying to get you with a confidence level, but that's not what it is. We're just 95% confident that it lies within that interval. 24. A state biologist is investigating whether the proportion of frogs in a certain area that are bullfrogs has increased in the past 10 years. The proportion of 10 years ago was estimated to be 0.2. All right. From a recent random sample of 150 frogs in an area, 36 are bullfrogs. All right. So we took a sample size of 150 and we ended up with a group of successes of 36. The biologist will conduct a test of P equals 0.2 versus P greater than 0.2. Which of the following is the test statistic for the appropriate test? All right, so let's write down our formula. Z equals P hat minus P, and that could be P naught, over the square root of P naught, be careful, 1 minus P naught. Notice I did not use P hat here, right? We do not use P hat here. So let's, P hat though equals X over N, which is going to be 36 over 150. And if I divide that out, I end up getting 0.24. So P hat equals 0.24. So I should have 0.24 minus 0.20 over 0.20 times 1 minus 0.20 over our sample size, and this should all be underneath a radical. Make sure that that's done that way, of 150. Okay, so this is wrong. Wrong. That's wrong. So now we're down to these two. Problem with this one is the denominator needs to be based on not P hat. Can't be based on the denominator. It can't be based on P hat. It's based on P. So 24 is D. 25. In the United States, 36% of the people who have a blood type that is A positive. All right. So they're telling us P of A is 36. From a random sample of 150 people from Norway, 66 had blood type A that was positive. Consider a hypothesis test to investigate whether the proportion of people in Norway with blood type of A positive is different from the US. Which of the following is the standard deviation used to calculate the test statistic for one sample z-test? First off, here's why it's a one sample. We only took one sample. We're comparing it to a known. Some people might think it's two sample, but it's one sample because we only took one sample. So for this is what we claim, and the formula is going to be Z equals P hat minus P over P naught times 1 minus P naught over N. And this should be a 0.36. So what is P hat? In this case, P hat is always X over N, which is 66 over 150. And that's 0.44. So we end up with 0.44 minus 0.36 over 0.36 times 1 minus 0.36 over 150. All right, well, we can just look at those real quickly and tell that they're not right. And they're asking for the standard deviation. All right, well, the standard deviation is this part underneath. So the one that has 0.36, well, that's not 0.36. That's not 0.36. That gets rid of those. Best answer choice for 25 is D. And 1 minus 0.36 equals that 0.64 that you see right there. 9. Suppose 26. Suppose a 90% confidence interval to estimate a population proportion was calculated from a sample proportion of 18%. and a margin of error of 4%. What is the width of the interval? Cool. So we would expect to have because remember, it's basically your center plus or minus the margin of error. So 0.8 plus or minus 0.04. Because all I do is take the 4 and divide it by 100. Same with the 18. Which means if I take 18 minus 4, I'm down to 14. If I take 18 plus 4, I'm up to 0.22. So that's my interval. Well, 0.22 minus 0.14 equals 0.08. So 26 is C. Now, there was a shortcut to that. I could have just gone 2 times 0.04, and that would have done the same thing because I'm adding and subtracting. So we can just double our margin of error, and that would tell us how wide our interval is. Oh, so 26 C. 27. Molly works for a meat producer and she needs to determine whether containers of ground beef have the correct fat content. She obtains a random sample of 120 containers of ground beef and finds that 84% have the correct fat content. Molly then conducts a hypothesis test of P equals 0.8 versus P does not equal 0.8 and calculates a test statistic of 1.1. All right. So this is a Z statistic of 1.1 with a p-value 0.273. Which of the following best represents the meaning of the p-value? All right. So p-value is the probability of getting a test statistic this extreme if the null hypothesis is true. So if p equals 0.80, all right? So that gets rid of this one and gets rid of that because it says because this say 84, if the population is 0.84. This says if the population is 0.8, if the population is 0.8, if the population is 0.8. So it could be one of those three. So probability of getting a test statistic this extreme given the null is true. The probability of observing a sample proportion within so our best, once again, let me restate the definition of a p-value. The probability of getting a test statistic this extreme or more extreme given the null is true. So we've already addressed the given part. So the probability of observing a sample proportion of at least 0.84 or at most 0.76 is 0.273. And because it was a not equal to, we had to use both because we had 84% and 0.80 minus the 0.84 tells me, oh, we can vary by 4%, but because it was not equal, it didn't have to be just above. It could have been below. I think I need to draw a picture of this. Best way to probably approach this is to say the picture and what we're supposed to be at is 0.80. What we're at was 0.84. But because it's not equal to, it's a two-tailed test. All right. And because it's not, and this distance right here between these two is 0.04. So I also need 0.04 here, which makes this 0.76. So it could be as low as this or as much as this. Those are be as equally as extreme. Only have to do that if it's two-tailed, not if it's one-tailed. Number 28. Chicken hatcheries employ workers to determine the sex of baby chicks. The hatcheries claim that the workers are correct 95% of the time. An investigator believes the workers' success rate is actually less than 95%. The investigators selects a random sample of chicks and finds the hatchery works has a success rate of 93%. Condition for inference was checked and verified, and the p-value of the test was 0.0322. If the null hypothesis is true, which of the following statements is correct interpretation of the p-value? First off, this was our p-value. Well, if it really is 95%, there's a 3% chance that we would get it um, as great or less than 93.6, 3.2% of the time. Of all random possible samples of size, I like that. 3.2% will result in a success rate of no. Oh, or less. Oh, if the null hypothesis is true, I'm sorry, I misread that part. So that they're telling us it's true. Then there's if it's actually true, 3.2% of all possible samples will result in the success of this or less. And once again, that's because the HO was P equals 0.95 and the HA was P is less than 0.95, and that's where that less came from. All right. 29, consider a hypothesis test in which the significance level is 0.05 and the probability of a type 2 error is 0.018. What is the power of the test? Power equals 1 minus beta, or 1 minus type 2. So power is 1 minus 0.18. So in this case, power is 0.82. So the probability of correctly rejecting is 0.82. All right, finally, number 30. Machines in a factory produce circular washers and with a specified diameter. The quality control manager at the factory periodically tests a random sample of washers to be sure that greater than 90% of the washers are produced with the specified diameter. The null hypothesis of the test is the proportion. Okay, so they're telling us our HO, P equals 0.9. The alternative is that the proportion of washers will is greater than 90%. All right, P is greater than 90%. Which of the following describes a type 1 error? All right, type 1 error means this was actually true, but I actually believe I reject the truth, I reject this, and I believe that it's greater than 90, but I'm wrong. So the test does not provide convincing evidence. No, the test provides convincing evidence. Anytime you're rejecting, it provides convincing evidence. So that gets rid of this one right here because this is did not provide. The test provides convincing evidence that the proportion is greater than 90%, but the actual proportion is equal. That's it. All right, let's look at this one. The test provides convincing evidence that the proportion is greater than 90%, but the actual is greater. That's not an error. That's doing the correct thing. And remember, error is um, rejecting the truth. So we rejected this when it was actually true. All right. Type 1 error is always possible because of sampling variability, sampling error. Appreciate you watching. I sure hope this helped and look forward to seeing you on the next one. Thank you.